If we want to reduce the energy consumption due to transport in our society, it's important to understand which is the physical basis of this energy consumption. In this chapter, we are going to focus on the physical magnitudes that determine the energy consumption of our vehicles. At the end of the chapter, we will be able to understand which are the magnitudes that we need to modify in order to make this energy consumption due to transport a little bit lower. We are going to analyze these three phenomena, that is inertia, the friction with the air, and the friction with the axis of the car. Let's start with the first, the inertia. Inertia is nothing more than the reaction against changing the velocity of some object. For example, if a car is waiting in a traffic light and start to move, we have to do a force in order for the vehicle to start moving. This is the inertia. And the effect of inertia is that if you want to change the velocity, you need to do this force. The equation, the formula that allows us to calculate how much force we had to do on an object in order for this object to start to accelerate is Newton's law. This is the famous law that tells us that the force that I have to do on this object is proportional to the mass and proportional to the acceleration that I want this object to take. Multiplying these two terms, I will get the force. This tells us that the larger the car, the higher the force. And the larger the acceleration, that is, if we want to go to change the velocity fast, very fast, the larger also the force. Once we have the force, we can calculate the work that this force is doing. The work is simply multiplying the force by the distance. And this gives us a value of the energy that it's required. Just multiplying the force by the distance, we get this work. If we substitute the value of the force that is giving me the Newton's law in this expression, I will get the work that at the end is the total energy. That is the energy that I need for a vehicle to start moving is the multiplication of mass, acceleration, and the distance where this acceleration is being imposed. Well, all this energy should come from my source of energy, that is the combustible and is the battery of my car in the case that I have an electric car. Well, as this force is required when we change the velocity, is important. This force is more important in the cities where we have traffic lights. We have crossings and we have to stop and start to accelerate. So this inertia is very important when we drive inside our city. And it is important to remember that it's proportional to the mass and it's proportional to the acceleration. So this means that if I want to reduce my energy consumption inside my city, I have to use reduced mass cars. So the lower the mass, the better the better the performance, so the lower the energy that I need. And I need to go with not high accelerations, large accelerations. I need to go slower. So if I want to go very fast, if I want to change my velocity very fast and then brake very fast, I will be dissipating so much energy. So this, notice that these physical expressions, this equation is telling me what I need in order to reduce the energy consumption inside my city. Okay, let's go to the second of the phenomena that I want to consider, that is the friction with the air. The friction with the air is a force that appears when the car is moving and the car needs to keep away the air from the path that is going. In that case, the air is reacting against being moved. It's also a kind of inertia of the air that don't want to be kept away from that point. And this makes that the air is doing a force against the car. So this force should be given by the motor. And when we go at constant speed, for example, in one road, in the highway, the only force that we are doing is this one. Once again, remember that Newton's law tells us that the total force on an object is the mass by the acceleration. When we go in the highway at constant speed, the acceleration is zero. So this means that the force is zero. This does not mean that the force of my motor is zero, but that the force that my motor is doing is just equal to the force that the air is doing against me. And this cancellation allows me to go at a constant speed. Well, at the end, the important force when I go at a constant speed on a road is this force as is given by this expression, that is 1/2 of one constant, that is the aerodynamic coefficient, that is a value around 1, multiplied by the density of air, and multiplied by the two terms that are important in our decision, that is the cross-section area of the car, that is the area that I will see if the car is moving towards me, that area, and multiplied by the velocity, the speed that car is maintaining, the velocity. The first thing that we have to consider is that it depends on the square on the velocity. So this means that if we double the velocity, we multiply the force by 4. So doubling the speed is not doubling the force, it's multiplying by 4 the force. And this is the first thing that physics tells us about going at a constant speed in one road. The other thing is that it depends on the cross-section of the car. So the larger the car, the larger the force that I have to do to keep this car moving. Well, once again, to calculate the work, I need to multiply this force by the distance that I'm traveling. In doing so, if I substitute the force by the expression that I obtain, I will get the amount of energy that I need to travel a distance d at a velocity v. And all this energy should be taken from my fuel. This is the final energy. This is the expression that allows to calculate the amount of energy that I need to do all this trajectory. Well, as it depends on the speed to the square, this tells us that this is important when I go at a high speed. This expression is not that important inside the city, because I go at a reduced speed, but for example, it's important in the highway. So this air friction is more important when outside the city, and the inertia is important inside the city. Well, now let's go to the final phenomena that we will study, that is the friction with the axis. In order to see the magnitude of this force, you can do a simple experiment, that is just trying to push your car. Just release the brake of your car and try to push it, and you will see that just with not much force, you can start moving that vehicle. You don't need to make this movement to be very fast. Just try to start moving. At the point where the car just start moving, even if it's a very reduced velocity, it means that the force that you are doing is higher, is larger than the force that the axis are doing against your movement. movement. And this means that this force is not much important in the movement of the car. So the technology have done that all our vehicles has this friction very, very reduced. So it's not much important. Well, at the end, the comparison against all of them, we can see that friction against the air is much more important than the friction with the axis. You can try this if you are going into the road and you try to put your head outside the car, and you will see that the air is doing so much force, and just in an area that is very tiny compared with the car. So imagine the amount of force that is doing against the full car, so the total cross-section of the car. So at the end, the two important facts of the of the vehicle movement is inertia and the friction against the air. And well, in order to reduce the energy consumption of my vehicles, of our vehicles, we need to reduce the velocity. So if we want to reduce the friction against the air, we need to reduce the velocity, because remember that there is a square, and we need to reduce the size, that is the cross-section, the area that I see in the car. So we need smaller cars that go to a much reduced velocity. And if you do this, the amount of energy that you will waste is so reduced compared to large sizes and large velocities. And inside the city, there are two equivalent magnitudes, but they're not exactly the same. We need reduced mass, so we need tiny vehicles that not have having light weight, not heavy weight, and we need to drive with small acceleration, so trying to be not impulsive, so trying to accelerate progressively and trying to move at a more calm, in a more calm driving. So this is what the physics tells us about the energy consumption and the energy waste in the transportation. Okay, in conclusion, the energy used in transportation is used to go against the resistance, two of them, the inertia and the friction with the air. In the inertia, we need, we have seen that the relevant magnitudes are the mass and the acceleration, and these are important inside the city. And in the air friction, the important magnitudes are the speed and the cross-section, the area of the vehicle. And this magnitude is important outside the city, in the roads and in the highways. And in order to reduce our energy waste in transport, we need to reduce the masses and the sizes of our vehicles and driving in modes that are more calm and not impulsive, trying to go at a lower speed and lower accelerations.